Good morning, students. Let me continue with Pythagoras theorem. Theoretical problems. Prove that 3 times the sum of squares of a triangle is equal to 4 times the sum of squares of the medians of a triangle. Very simple question. Prove that 3 times the sum of the squares of the sides of a triangle is equal to 4 times the sum of squares of the medians of a triangle. Prove that 3 times the sum of squares of the sides of a triangle is equal to 4 times the sum of squares of the medians of a triangle. So D, E, F. Right? So in this, prove that 3 times the sum of the squares of the sides of a triangle. So sum of the squares of the sides AB square plus BC square plus CA square is equal to, prove that the 3 times the sum of squares of a triangle is equal to 3 times the sum of squares of a triangle is equal to 4 times the sum of squares of the medians of a triangle. 4 times the sum of squares of the medians of a triangle. AD square plus DE square plus CF square. So how to do this one? So in this we have to use Apollonius theorem. Just now in the previous classes I have proved that Apollonius theorem. Similarly you have to apply it here. So by Apollonius theorem, what you can say? AB square. So sum of squares of two sides of the triangle. Sum of squares of two sides of a triangle is equal to what? Twice the sum of squares of two sides of, what does it state is, sum of squares of two sides of a triangle is equal to twice the square of median plus twice the square of the base which bisects the median. Twice half the side of the base. Twice half the side of the base. Half the side of the base means BD which bisects the median. Once again I will tell what is Apollonius theorem. Sum of squares of two sides of a triangle is equal to twice the square of the median plus half the third side of the base. If these two sides are there, then this becomes the base. Half the third side of the base. So twice the square of half the third side of the base, provided AD is the median. Right? Once again, sum of squares of two sides of a triangle is equal to twice the square of third side which is half. Third side means this one which is half. Twice the square of third side, twice the square of the third side which is equal to half plus twice the square of the median which bisects the third side. Bisects means already we know AD is the median means this one. So sum of squares of two sides of a triangle is equal to twice the square on half the third side plus twice the square on the median. Now this one write as this 2 times AD square plus 2 times, what is BD square? BD square is nothing but half of BC square. Right? Half of BC square. So this is nothing but 2 times AD square plus 2 into this can be written as 1/4 of BC square. Right? So 2 times AD square plus half of BC square. Right? So AB square plus AC square is equal to, like this will be 2 times AD square plus half of BC square. Next, similarly you can write by Apollonius theorem. You can write similarly AB plus AC is given. AB plus AC. Now consider BC plus CA square. BC square plus CA square, BC square plus CA square. So for this, again consider BC plus AB square. I am sorry, BC. In the same way, similarly, if B is the median, similarly, if B is the median, next what you can say? BC square plus AB square is equal to twice AE square plus similarly half of AC square. Directly write down. Next, now if C is the median, if CF is the median, if CF is the median, what can you say? If CF is the median, AC square plus BC square is equal to twice AF square plus half of AB square. Right? Now add the LHS part. AB square plus AB square, AC square plus AC square. Next, BC square plus BC square. This is nothing but 2 times what? AB square plus BC square plus AC square is equal to LHS I have added is equal to 2 times AD square plus 2 times AF square plus 2 times AE square, BE square. B is the median, so here B will come. Please make a note of it. 2 times AD square plus 2 times BE square plus 2 times please make a note of it. B is the median means BC square plus A square is equal to 2 times B square plus half of AC square. Now CF is the median. Since CF is the median, so BC square plus CA square is equal to 2 times CF square. Please pardon me, I have written wrong. AC square. Since CF is the median, this is the median, so BC square plus AC square is equal to twice CF square plus half of AB square, right? So, pardon me, I have written wrong once again. This is equal to 2 times AD square plus BE square plus CF square plus half of, take the half common, half of BC square plus AC square plus AB square, right? Half of BC square plus AB square plus AC square, right? Now bring this over here. What I am saying is, bring this half to here. 2 times AB square plus BC square plus AC square minus half of same thing, AB square plus BC square plus CA square is equal to, write this again, take 2 common in this. Take 2 common in this. 2 is there, no? 2 times AD square plus BE square plus CF square. Next, in this take A, this all you take common. 2 minus 1 by 2. AB square plus BC square plus CA square. Just algebra. I am doing just algebra, addition, subtraction, multiplication. This remains as is. 2 times AD square plus BE square plus CF square. Now 2 minus 1 by 2 is 3 by 2. Right? 3 by 2 AB square plus BC square plus CA square is equal to 2 times AD square plus BE square plus CF square. Now cross multiplication. 3 times AB square plus BC square plus CA square is equal to 2 to the 4. 4 times AD square plus BE square plus CF square. So hence the theorem, 3 times the sum of squares of sides of triangle is equal to 4 times the sum of squares of the medians of the triangle. Very simple. Just apply Pythagoras theorem and simple calculations like addition, subtraction. If you do, you will get the answer. Another question. Prove that the sum of squares of sides of a triangle is equal to 3 times the sum of squares of sides of a triangle is equal to 4 times. Just bring this over here. 2, again take 2 common in this, and again from this 2 and half. 2 minus 1 by 2 is nothing but 3 by 2. Cross multiply, you will get the answer. This remain as it is there. Next one. In a triangle ABC, D is the midpoint of BC. This is another problem. In a triangle ABC, D is the midpoint of BC and AE is perpendicular to BC. In triangle ABC, D is the midpoint of BC, AE is perpendicular to BC. In triangle ABC, D is the midpoint of BC, AE is perpendicular to BC, right? D is the midpoint of BC and AE is perpendicular to BC. Prove that AC square is equal to AD square plus BC into DE plus 1/4 of BC square. So how to do this one? So AC square is equal to AD square plus this one BC into DE, BC into DE, something they give. So don't panic and don't be too much tense about this problem. It's nothing confusion. Square on the hypotenuse is equal to sum of squares on the other two sides. You have to apply here. They have given very big proof that by seeing this one will get confusion. Array, what is this? The very big problem is given. Very big problem is given. So it's nothing like that. Just you go on, apply Pythagoras theorem, you will get the solution. Consider triangle AEC. Consider triangle AEC. Square on the hypotenuse. AC square is equal to AE square plus EC square, right? Therefore AE square write as is. EC square, how will you get EC square? By adding this. EC square, how will you get? ED plus DC whole square, right? So AE square is equal to AE square plus, apply A plus B whole square, DE square plus DC square plus 2 times ED into DC, right? Now AE, are you following? A plus B whole square, A square plus B square plus 2AB. So DE plus DC square plus 2 times ED into DC. Here you need to apply some properties here. Since D is the midpoint given, no? Here in the problem, D is the midpoint of BC given. So since D is the midpoint of BC, what can you say? Since D is the midpoint, therefore BD is equal to DC, right? BD is equal to DC. So wherever BD is there, write on DC. So here DC is there, write down AD plus into DE. So just write like this: AE square is equal to AE square. Here you can see that AE square plus ED square. Mark, club these two. AE square plus DE square. AE square plus DE square is nothing but AD square, right? So consider triangle AED. In triangle AED, square on the hypotenuse. AD square is equal to what? AE square plus DE square, right? Square on the hypotenuse is equal to sum of squares on the other two sides. So therefore, AE square plus DE square is nothing but, what can you write? AD square plus BC square plus 2 times DE into DC, right? So here you see here AD square, just we are near to the problem. AC square is equal to AD square plus DC. DC here it is there. So DC is nothing but this length. How will get? Half of BC. DC length is nothing but half of BC, since D is the midpoint given, right? Plus 2 times DE. DE it is as it is. DC again, DC is nothing but half of BC. DC is nothing but half of BC. This one, suppose if this is 6 and this is 6, total length is what? 12. 12, how will you get? Here half of BC. BC length, just I am taking example, BC length is 12. Half of BC 6, that is nothing but BC. Just take this example, DC is 6, DD is 6, so total length is 12. So if I want to calculate this DC length, I am saying that DC is nothing but half of BC, half of 12 is nothing but 6, right? 2 gets cancelled. So AC square is equal to AD square plus 1/4 BC square. So here we are nearer to the problem, plus DE into BC, DE into BC, hence the theorem, right? So it's very simple. You consider this triangle and apply Pythagoras theorem, and again this triangle you have to consider. First you have to consider this big triangle, next you have to consider this small triangle, then some conditions you have to apply here. Since BD is equal to DC, DC length is nothing but half of DC. So just I applied that one. DC length is half of BC. I applied this one. There ends the solution. In the same way, you can prove that another one. Just I am not going to prove it. Just I will write it. Yeah, and this is another bit. AB square is equal to AD square minus BC into DE plus 1/4 of BC square. This one, same thing you prove by yourself. It's very simple. I am not going to do it because both are same. Third one, this you try by yourself. Please try by yourself. Second one, first one I did, second one you do it. Third one, third bit is what? AB square plus AC square is equal to 2 times AD square plus half of BC square. So mark this as 1, mark this as 2. Add these two conditions. I told you this you have to do by yourself because it is very simple. So now you have to consider this triangle. AB square is equal to something, you do it and you will get the solution with this. Same like first bit you do second. Already I have written PT by y. Please try by yourself. Now add these two. AC square plus AB square is equal to AC square plus AB square is equal to what? AD square plus AD square is nothing but 2AD square plus BCDE minus BC will get cancelled. 1/4 BC square plus 1/4 BC square. So 2 times AD square, take BC square common, 1 by 4 plus 1 by 4. Right? 2 times AD square plus BC square, 1 by 4 plus 1 by 4 is 2 by 4. So half of BC square plus twice AD square is equal to AC square plus AB square. So in this way this problem finishes. In triangle ABC, D is the midpoint of BC, D is the midpoint of BC, A is perpendicular there, that is very simple, hence the solution. So with this difficult problems are finished. Again still some more problems are yet to be finished. So mostly it will take 3 or 5 classes. Thank you students, have a nice day. Please subscribe my channel by clicking the blue color icon and don't forget to subscribe it. Thank you, have a nice day, bye.